Okay, this is a differential equation. Okay, so this is an equation that has, well, here's a double derivative here of y, and here's a single derivative of y with respect to x, and here's just a function of y. It's an implicit function. Presumably there's lots of x's behind that. So this is y as a function of x. Now, a differential equation, rather than a normal algebraic equation, when you solve it, we're solving for a function here. So we're trying to solve this for a function of y. Now, I'm going to be very generous and tell you what the answer to this one is. Okay, so the answer to this function of y is y equals x squared e to the k x. Okay, so this is the solution to this differential equation. So we're not actually going to solve this one to find what this is. What we're going to do is just verify that this is actually the solution to this. So what we do is we're going to take a bunch of derivatives, well, two in fact, two derivatives of this, and then substitute it in to this equation to show that it equals 0. Okay, so this just takes a whole lot of legwork to work this out. Okay, so let's have a go. All right, so y prime of x dy dx. Here we use product rule. So let's go with, we take the derivative of this one, so 2x e to the kx plus x squared times k e to the kx. Okay, so we should be getting to a point where we can do product rule quite simply in one line. Okay, we could simplify that a little bit if we take out, let's just take out the e to the kx. E to the kx, no, actually, we should just leave it. Let's just leave it. Yeah, that sounds good. Nah, we'll take it out. E to the kx, 2x left over, plus kx squared. All right, so there's our first derivative. What about our second derivative? Y double dashed of x, second derivative to go in this bit. I'm just mixing my notations up a little bit here, but that's okay. All right, so we need to take the derivative. We'll take the derivative of this line, the first line, because I'm just going to have to expand that out again. Okay, so what have we got? We've got 2e to the kx. Okay, so that's the derivative of that bit times that one. Now we want to go the derivative of this one plus k, or 2kx e to the kx plus the derivative of this one. Now the derivative of this one is the same as the derivative of this one with a k out the front. Okay, so I should get 2kx e to the kx. Okay, that's the derivative of the x squared times that, plus the derivative of this one, so I get x squared k squared e to the kx. Okay, so I can simplify that a bit because these add up in the middle. These are like terms, so I've got 2e to the kx plus 4kx e to the kx. So that's those two added up, plus x squared k squared e to the kx. Can we, well, I could take out e to the kx again. E to the kx, bracket, left with 2 plus 4k, or 4kx even, plus k squared x squared. And there we go. So now we've got our derivatives, these two derivatives. We're going to substitute them back into here and see whether that's the right solution. Okay, so maybe I will just rub these out. I've got them written down here. So we'll substitute them straight in. So hopefully you can double check and see if I'm cheating. So let's substitute it in. Okay, kx times the second derivative. Now the second derivative was e to the kx times 2 plus 4kx plus k squared x squared minus, we're going to run out of room, k squared plus k dy dx, which is e to the kx of 2x plus kx squared. Yeah, I think I've got that right. Minus k squared times x squared, because y is, I'm saying is x squared, e to the kx squared. No, hang on. No, just kx. Whoop, there we go. Done. Now that's the left-hand side of the equation. Okay, let's expand it out and see what we get. Okay, so I'm going to have to write a little bit smaller and maybe zoom in because this is going to be quite long. Okay, so equals, what do I get here? I get 2kx e to the kx. Okay, expanding this in. I get plus 4k squared, 2k's times x squared, e to the kx. Then I've got, what have I got here? I've got a plus a k cubed, k times k squared, x cubed, e to the kx, minus. Now all these terms are going to be minus because of this minus out the front. So minus, what have I got here? I've got k squared, oh hang on, we'll put the ex in, we'll just do this times this, so I get minus 2x squared k squared, or k squared x squared, minus 2k squared x squared, e to the kx, minus, so that's this one multiplied by this one multiplied by the last one, I get minus k cubed x cubed, e to the kx. Then this one times this one, minus 2kx e to the kx. And this one times this one, minus k squared x squared e to the kx, minus this last bit on the end, k squared x squared e to the kx. All right, we fit it in. Okay, so I've got 2kx. Now is there a minus one of those? There's a 2kx e to the kx, so that one and that one might cancel out. What about my x cubes here? I've got x cubes and I've got k cubes e to the kx. These two cancel. That's lovely. Now here I've got k squared x squared, k squared x squared, k squared x squared. I've got minus 4 of them. 1, 2 plus 2, that's 4. Minus 4 plus 4. They all cancel out. And the whole thing equals 0, which is the right-hand side of our differential equation. We have verified our solution of y equals x squared e to the kx.